Hello all, and in this particular video, we'll be studying linked hash map. For this, the prerequisite is to go through that hash map video because linked hash map, is based on hash map itself. So if you've not seen hash map video, linked hash map, you won't be able to understand properly because a lot of things which I have explained in hash map video, which I cannot explain it here. So what you can do, if you have not watched, I will put the link in the description. You can go and see. So let's start with linked hash map. And as you know that, as you may have guessed by now that a linked hash map class, which is written in Java collections, it actually extends hash map class itself, and which and also it implements map interface as well. So this is something like that, like public uh, class linked hash map k and v is used for generic. Like here, you can give anything like string, integer, or even your custom object like employee, etc. Okay, the key can be of those type. However, you should be taking in the constraints, like what should be the rules for key that you should be reading. And then value is also same, like string, integer, and all those things. Okay, so etc. So this is like that. And what it does, I'll delete this first. And what it does now, it extends hash map class. So something like that, extends hash map. And in the previous video, we have already traversed this particular class, this hash map, in a very detailed way, that what are its internals. And then it also implements map interface because it's map k comma b. Okay, so this is how it does. And this is the class which internally we'll go through. So you already know that there is a node in hash map which contains hash value, key, and value, and the pointer to the next node in case of collision that will be required. Okay, so here what happens in this particular class, there is a nested class or inner class, you can say, uh, something like this: static class entry. And this will be again k and b, key values, which is representing in the generic format. This extends this inner class. Okay, this is an inner class, and this inner class extends, you guys have guessed it by now, it extends hash map dot node. So node is the inner class of hash map, right? So here they are extending it. So all the properties of node class will come in this. Okay, and let's see that what's inside this class. This will contain entry type, which will be before and after. And rest all the four things which we have talked about, like value and key and hash, and the next pointer will come from this node class. And then there is a constructor inside this entry int hash k key v value node k v next, that is for next pointer. Okay, and then this constructor calls super keyword, that means super class constructor, that is parent class constructor hash. So if you don't know this concept, I'll say that go and study that how will you call parent class constructor or super class constructor. Super keyword is used. So this is how this node is created. So why the question now will come into your mind, that why do we do that? So what exactly hash map does, first of all, sorry, what exactly linked hash map does is, so linked hash map, it maintains insertion order. Unlike hash map does not maintain insertion order. By insertion order I mean, let's suppose this is the array you can resemble from hash map video. Okay, and this is 15th, this is 0. Let's suppose some node was inserted here, and I have inserted, let's suppose this is an integer key value. So let's suppose 1 is the key and 1 is the value to keep things simple, and there will be some xyz hash code, and here it will be null for now. Let's suppose we have added one more, and this is something, let's suppose 5, and let's suppose this is what, let's keep it simple, actually xyz xya. Okay, and this is also null. But let's suppose when we entered one more value and it by chance collided with your first key's hash, so what it will do, let's suppose its value and key is 17th and its hash is same somehow, so it will be mapped onto this index itself. Okay, here itself. So what will happen, this null will go away, and in place of this the memory address of this will be stored. So now we have inserted the values in order. First we have inserted 1, then we have inserted 5. Okay, and then we have inserted 17. So in the hash map we didn't have anything which will tell you that in which order you have inserted the values, right? But here in the linked hash map, this order is being maintained. So this is the only property of linked hash map which makes it different from hash map. So now you might have understood that why we have created this particular entry node when we already have this node, right? You can see here that there is before and after of type entry. So of type entry means this the same. So that means it's storing a couple of more addresses into the memory, sorry, into this node, which will say that, I mean, this will store the address of the node which got inserted before this particular node, and this will store the address of the node which will be inserted after. Next will be same. Next is used for collision, so always remember. So now you can imagine the node like this, like this one. Okay, like this. So here there will be a before node, I mean in this object something like this. This will be after. So this will be storing memory address of, two more nodes similarly, like this, and uh, this is the entry node here, which we have discussed above, and inside that there is a hash map node as well, right? So you can imagine something like this. What will be like? Here there will be key, here there will be value, here there will be hash, here there will be next. So this next is for maintaining chaining, basically, when collision happens. Okay, so with this, that there is this node, entry node, which is there, and as I said that this, since there is before and there is after, this will create a doubly linked list, right? What is doubly linked list? Let's revise quickly. Something like this, right? Previous, next, and here data. So this stores the next elements, and this stores the previous nodes, right? And similarly this one will point to this one, and this like this one. Okay, so this is a kind of doubly linked list which is created. And why it is being created doubly linked list? Because it has to maintain the insertion order, like which node is before which node and which node is after which node. So here instead of previous and next, there is before and after. So you can imagine the object even like this if you wish to. I am just showing you different things so that you should remember and you should not forget. So like this also you can imagine, and there will be obviously four things like key, value. So your imagination is really important, otherwise it's very difficult to understand the concepts. Okay, so this will be the hash maps node. So like this, this stores, and now so let's see that how it is being inserted. So as we have seen earlier that we have inserted 1, 5 and 17, but before that, going to that, I'll tell you that there are two fields, I mean two entry nodes, which is already created. One is head, okay, and one is let's do it here, tail. And how they are being written in the code is something like this: transient, linked hash map dot entry kv. I hope it is visible. Sorry for it went too long. And this is head, and similarly this is written here: transient, linked hash map key value dot entry. Sorry, I think I made a mistake here. Here it will not be kv, it will be linked hash map dot entry key value, and this is state, something like that is written. Okay, so these are the two nodes which will be similar. Let's put before and after here, and let's put before and after here also. Okay, so this is how it is. And that when this will be empty, like you can see that after will point to tails, and this will point to the previous of tail will point to head. Let's not go into that, it's not very important as well. So here let's see this one. So this is how there is an array, right? Which is inside this 0 1 2 3 4 5 and 15, 0 to 15. So we have entered, let's suppose, one first node, and this will be similar. So here 1 1 xyz null. Okay, so this will be there, which is the after will point to this. Okay, and the before will point to this for now. And now this is the before, and this will be null for now because there is no entry after that. After that we have inserted, so this is, let's suppose, here. After that we have inserted 5, I guess, right? So 5, and this will be null. Oh, sorry, this will be 5 5 and xya, I guess, and this is again null. So after, now this was null, right? This will be crossed. Let's delete it, and what it will do, it will point to this node, and this is before will point to this node, right? And now we have entered 17 here. So after, and the hash of 17 was same as of 1, so there is a collision. Here it is null. So how collision is handled, this null will go away, this one, okay, which I am dropping. So there will be a pointer from this null, which will let's take another color. Okay, this is the next pointer here. But you'll see that when this node is added, this is added after 5. So here this will be pointing like this. Now this is becoming a bit clumsy, but it's okay. And its after will be null. Okay, and oh, I forgot to tell that after, actually the after will not be null, sorry, my bad. Here where I told that it will be null earlier, it won't be null actually. It will earlier store this tails address. This is completely my bad right now. So let me tell you that previously, before adding this, right, when this was not added, so there has to be one pointer which will point to tail. Okay, and when this node came in picture, this reference will be deleted, and what will happen, uh, this reference is created. Okay, similarly, before this came into picture, before this one came into picture, it was pointing to this. Okay, and this will be deleted now. So and tails before is pointing to this head. Okay, earlier when it was started, but now tails before will point to this. So this is my bad in explanation, but I hope you understood. If you have not understood, comment me down. I can make a separate video again, but I don't want to edit all those things again. So like this, and now when this came, right, so this will not be null actually. So this is my bad, I completely forgot. This will point, let's take its color different, then I think we'll understood more. So let's take, so this will point to tail. Okay, and when this will be dereferenced, and what happened here, this before will call this. Now this is very clumsy actually. Okay, and this before will call to this. This is very clumsy now, and you won't be understand it properly even after a lot of colors. So let's see how it does look in simpler way. Forget about this this array for being. So let's see how will it look here. So it will look like, let's create 3 nodes first. First like this was one xyz and null earlier, okay, but when 17 will come, will do. So this is another here, and this was 5 xya. This is also null for now. I'm not making this before and after for now. And after that there was something 17 whose this was value was collided, okay. So here this will be null for now. How will it look now? Here let's put head, okay, and here let's put tail. So this will look something like that. First let's put a reference of this null here. So this will be going down and this will point to this next pointer. I hope you are clearly able to see this. And this head actually here will point, after of the head will point here, okay, and before of this will point here, right? Before of this will point here, after of this will point here, before of this will point here, after of this will point here, before of tail will point here, and after of tail will point here. So this is the simplified representation of how it stores insertion order. So I hope now you are clear. All those operations which are there in the hash map will be same. With this I'll wind up the class, and if you want to follow me, my ID is Thriver Ashish on Insta, Twitter and LinkedIn, where I post daily something related to educational stuff. If you want